we are going to see one-dimensional problem again, a simple problem. This question may ask in the university with 8 marks. It will not be a 16 marks. Displacement at point, strain E, stigma, element stiffness matrix and strain energy U. So now we have to calculate the displacement, strain energy, stress, everything. So consider, now this we will see the bar. Consider a bar as shown, cross-sectional area of the bar is 750, Young's modulus is this one, U1 is 0.5 mm, U2 is 0.625 mm. So what I am doing is that problem is given, this is the bar and they have given U1 and U2 or the displacement that bar has, and the point P is here we have to find out the displacement, that is our objective. The distance x1, this point, coordinate point is 375 mm, this coordinate point is 500 mm, this coordinate point is 575 mm. With these data, the material properties data, displacement data and the coordinates data are given and it is well written. And with these data, we have to find out this five variables, that is we have 5 properties, we have to find it out of the bar. So now we will get into the problem, and this is the problem. It is written x1, this one, x1 is equal to 0.35, 500, x2, everything I have written. First we will find out the length of the bar. So length of the bar can be found out by difference of this coordinate minus this coordinate and this coordinate. So 575 minus 375 will give you the 200. This is the whole length of the bar. The same way we can find out this value and you can find this value. So this distance 1 to P distance is this difference of this coordinate and this coordinate that you are getting. This is 500. This is 500 mm. So 500 minus 375, that is x is equal to 125. So we got this. Now we will use the displacement function that find out the displacement at the point P. We will write this as a point P. Displacement at point P, n1 u1 plus n2 u2. The n1 formula is 1 minus x. This x values is the distance between the 1 and P, that is 125. This is L minus x, not 1 minus x, L minus x. That is 200 minus 125 divided by 200. This is L is the length of the bar. The same thing here, 125 divided by 200. So this is the value of getting points. No need of, don't use any units over here. This is state functions. So here also the same thing, x by L, you got this. Now apply this n1 and n2 in this equation. This equation u1 and u2 are given in the problem. So if I do this, displacement at P will be 0.5781 mm. Now I am going to find out the strain, that is strain displacement in the degree of freedom. So the degree of freedom, displacement matrix is this one, minus 1 by L, 1 by L. So I got this. So U is the degrees of freedom, that is U1 and U2 displacement. So this is given in the problem. So multiply this and you get the answer. Strain will be E is equal to 6.25 to the power of minus 4. And that is the strength we described by the Hooke's law. So stress is equivalent to Young's modulus into strain. The strain we have find it out. No need, don't use any dimension because strain is a dimensionless quantity. So from here this is multiplied, so into 10 to the power of 5. This is given in the problem, and 6.25 10 to the power of minus 4 we have calculated, and this should be multiplied and you get 6 Newton per millimeter square. So because force by area it should be Newton per millimeter square. So one dimensional bar stiffness matrix is given. Stiffness matrix on the another AE by L 1 minus, this already we have studied in many problems. This is the stiffness matrix, AE by L. So area, cross-sectional area it is given, Young's modulus is given, length of the bar you know. So substitute these equations over here. When you substitute this equation you get this. So multiply inside, you will get the stiffness matrix, or you leave like this. Now last one is strain energy. The strain energy is the formula you know, half into kx square. This is what, okay, x square. X is some displacement So the x gives you the degrees of freedom. X square can be written x into x. So this is the displacement u into u, that is u into u transpose. When you apply the same thing over here, you cannot multiply. So the transpose of one matrix, one displacement, same displacement, and the real matrix will be multiplied. So I am going to half into u1 7.8 feet. This k is what? You have find it here. You have find it. This you substitute and this you substitute, and u1 this is this k value and u value, star value and u value, u transpose. That means you got this value. So now I will take this value. Now I multiply this value inside. So that's what I done. And this value got, and you will get 1 by 1, 2 by 1 column, 2 by column 1 matrix. When you multiply this, again this I have taken, again I multiply this and this, and I got this equation. This equation. So this u is equal to Newton. See, look at this unit, Newton per millimeter. See, half into kx square. K oda unit வந்து என்னது Newton per millimeter. This is per millimeter square. So k oda unit, this is millimeter, the x square it is millimeter. So this gets cancelled. You will get Newton millimeter. So please remember this. The strain energy equation is Newton meter or Newton millimeter or Newton centimeter can be. So I have presented this is very easiest problem. The only thing you should mug the formula B displacement matrix, my n 1 by L by minus 1 by L, that is stiffness matrix. The strain energy half U star transpose K into U star. This must be remembered. And how to calculate the length of bar, length of the difference of the coordinates. That's all. Then n1, n2. N1, N2 to find out the displacement. So remember all this in a proper way. Thank you.